Good morning. I'm on site here at Embedded World 2022 and joining me today is Anton from Broadcom. Anton is the Business Development Manager for LEDs, and as you can probably guess, we're going to be talking about Broadcom's LED portfolio. So Anton, before we start talking about some of your products, can you tell us what Broadcom's main LED markets are?
Yes, of course. Thank you. Yeah, so Broadcom traditionally serves several markets. So the main markets for Broadcom since many, many years are the industrial area, for instance. Okay, so this is also coming from the past, so from the old HP times. So we have a long history in the industrial area. So like HP, Agilent, Avago Technology, you may remember, or you may have heard that. And from that time, we were always serving the industrial area with different kind of LEDs like chiplets, standard LEDs, 7-segment displays. So this is a range which we already have since a very long time, right? Another market which we are serving is the signage market. Yep. So we call it electronic signs and signaling. This is a market where we are serving the big video screens, information signs in general, etc., traffic signs, traffic displays, etc. And for us, it's also one of the biggest markets too.
Okay, fantastic. So I understand that Broadcom employs the latest materials and process technology to produce its LEDs. So can you talk about some of the materials you use and the benefits that they bring?
Yeah, sure. So if I come back to the signage market, for example, we have materials used for the lead frame. So there are two materials, for instance. One is the mild steel, which is traditional lead frame material, which is also used for through-hole LEDs. So it's already existing for quite a long time in the market. But there is also a copper material. So copper has an advantage that it has a better heat dissipation from the leads. So that helps also to get the intensity and the heat from the PCB board. Yeah. So that's one example. And another technology, for instance, is phosphor converted LEDs. Yeah. So that's what we are seeing also for white LED technology, right? So you have a blue dye with phosphor material on top. So you can convert the blue color into a white color, for instance. But in the meantime, you can also do that with other colors, like amber, for instance, or a reddish color. Yeah. So that's also a trend for the future.
Yeah, brilliant, thank you. Now, Broadcom has a range of high-performance LEDs for signage applications, as you've mentioned. So how do they fulfill the traffic regulations EN 12996 and railway specs according to EN 15153?
Okay, so there are 2 points here. So one of them is the beam angle. Okay. So that's quite important because there is an instruction to have a certain beam angle in these kind of traffic applications. So we are fulfilling that with a viewing angle which is minimum 30 degrees. So typical 33 degrees. So we are guaranteeing that this is within the EN 12966 specification for traffic. And the other point is the color. So the color of the LED itself needs to be within a specific range. I can give you another example for the white color, for instance. The white color needs to be in a range of white bin C2. So that's defined under the traffic regulation. And we are fulfilling this white color with our LEDs.
Okay, fantastic. I understand you also serve the market with different surface mount packages for monocolour and full colour signs. So how do you increase their tolerance in environmentally hostile applications?
Okay, so for those LEDs where we have harsh environments, for instance, we have special LEDs which are having an epoxy material. Okay. So there are two materials you can use for LEDs, epoxy material and silicon. And in harsh environments, as you know, there is a lot of pollution, and there is, of course, also, from the cars, there's pollution, etc. So, and this could also attack the LED itself, so also the LED dies, for instance. So epoxy material helps to prevent this in general, right? So while silicon material is more weak material, so there is a risk that this kind of pollution can get inside of the package.
Yeah.
while this is not a big risk for the epoxy material.
Okay, fantastic. Now let's take a scrolling LED sign as an example. Now these signs often feature hundreds of LEDs in close proximity. So how do you ensure the reliability and performance of your products in an application such as this?
Right, yeah. So of course during or while releasing an LED, we are doing some lifetime tests.
Yeah.
So usually they are lasting minimum 6,000 hours.
Okay.
So this is, we are driving them all the time. So during these 6,000 hours, so we can see the degradation
Yeah.
of the LED over the time. Additionally, we have reliability tests. So we are checking from our side also if there is any fallout during production time, etc., with our LEDs, and then the parts are getting qualified from our side. Of course, we can give all this data also to the customers. So if they are asking for lifetime data, reliability tests, etc., that's of course available.
Okay.
Additionally, as I said, we have parts which have materials like the epoxy material, which ensures that they have a long lifetime, in general.
Okay, fantastic. And what criteria does an engineer need to consider when choosing an LED package for signage in particular?
So there are several criteria. First of all, they are checking, of course, is it an outdoor or an indoor application, right? So if it's an indoor application, then they can use smaller LED packages. So there is, of course, a certain pixel pitch they can use. So pixel pitch means the distance between the LEDs, right, on a board. So if you are indoor, you can also stand close to the board. That's clear.
Yeah.
And if you are close to the board, then the LEDs need to be very short to each other, right? So that's really needed. Yeah. If it's outdoor, then you have bigger pixel pitches. Yeah, could range above 10 millimeters, 12, 16 millimeter pitch between the LEDs. Of course, there's a certain distance, right? So this could be 20, 30 meter, 40 meters. So if you look at a football stadium, for instance, there's really a huge distance about this. And usually you are building up RGB pixels with 3 different colors, red, green and blue LEDs. So it's not a 3-in-1 package. It's really one red LED, one green LED, one blue LED, similar to this, for instance, right? Yeah. So you build up a pixel with those LED. You are using one red, one green and also one blue LED.
Right, okay.
Yeah. So these are the criteria I have to look at, for sure. As I said, pixel pitch is quite important for this criteria. And if they need to use small package types like PLCC6, PLCC4 LEDs and RGB, we have this type of LEDs also available in different sizes, ranging from 3.5 to 2.8 millimeter to the smallest one is 1 by 1 by 1 millimeter only.
Perfect, thank you. So what applications are these products specifically designed for?
So those products are designed for instance, gas price signs or signage for gas stations, for instance. You also have to look at what kind of LEDs you are using, right? So for gas price signs, there are 2 possibilities. You can use a round LED, for instance, or you can use an oval LED. An oval LED for gas price signs is quite important because the oval LEDs has 2 viewing angles, 100 by 40, for instance. So you have 100 degrees in one direction and 40 degrees in the other direction. And with this viewing angle, it also helps that the person can read the information from the side. Right? If you have a round LED in this kind of application, then the light is only going into one direction. So if a person stands close to the board, but at the side, he's not able to read the information, right? So for gas price sign, it's really important to have an oval LED instead.
So as someone's driving past, they can see it as well.
Correct, yeah, that's it,
Fantastic.
Another application, of course, is bus panel signs. I think that's really very common in the meantime. You see the white LEDs on the display, or you see the destination of the bus, etc. Similar to train stations and trains in general. So LEDs are really everywhere. Then other applications are highway signs, what I already mentioned before, right?
Yeah.
So the big signs on the highway, also in the UK, you can see that.
Yeah.
In the meantime, they are also changing to full color signs, so that you have RGB ones, not only the red and the white color or only the amber color, but also RGB. Then in Italy and Spain, you can also see the big pharmacy crosses.
Mm-hmm.
Yeah, so that's something you don't see in Germany. I don't know how it is in the UK.
Yeah,
but
not often. No, not
it's
in the
very,
UK.
very rare. Yeah, over here.
Yeah.
And there are a lot of other applications where you can use LEDs for signage, right?
Yeah.
Even in the areas for advertisements, for instance. In the big shopping malls, you can see that where they do advertisements, right? For products, etc. So,
I'm sure there's loads at the exhibition today. So let's talk about Broadcom's chip LEDs.
Mm-hmm.
You have a range of high quality chip LEDs which are small in size, have high efficiency and a low power consumption. So could you tell us about the most common packages in this range and their features?
Mm-hmm. Okay, so for chip LEDs, as I said, it's a product range which we have already since many years, more than 40 years already. So these are the common package types like 0402 package, which is a very small, tiny one. It's only 1 millimeter by 0.5, so really very tiny. It's only for some things like handheld, etc., where you don't need enough light, etc. Then other packages like 0603, 0805, 1206. So these could be top view versions, but there are also versions which are rectangular, for instance. Okay. And other ones are available which you can mount on the back side of the PCB board, for instance. So usually you have this hole on the PCB board and you can put the LED on the back side of the PCB and the top of the LED is looking out to the other side. Okay, so that's also available. And then of course you have bicolor version, red-green typically, but also blue-green, etc. And RGB also for chiplets. Yeah. But this is usually used for status indication, right? Okay. So it's showing you on, off, for instance. Okay, so red means there is an error, for instance, right? So usually these parts are not used for any kind of signage applications, besides a 1 by 1 millimeter chiplet, which are now getting to use for indoor video wall applications too, because you can create a very, very narrow pixel pitch. So it looks like a high definition screen a little bit, right? So also a quite interesting application.
Yeah, got a wide range there, fantastic. Can you also tell us about your infrared products portfolio? So what packages do you offer there and which applications are you targeting with these?
Okay, so the infrared range we built up 3 years ago. It's in the meantime a very complete portfolio. It's also containing again the chiplet range in infrared. But also other package types like through-hole parts, like PLCC2 or PLCC4 parts with a lens on top, high power solution, but also our SMT Lamp technology. So this package here, what I showed before, which is usually for video wall applications, is also available as an infrared part. Okay. So the reason for this is to replace this kind of SMD technology, or to replace the traditional through-hole LED technology with SMD technology, right? So what is usually missing for SMD are reliable parts with a lens, right? With a very narrow viewing angle, right? That's something you have with through-hole LEDs, right? So through-hole LEDs are having viewing angles like 6 degrees, 10 degrees, 15 degrees, right? If you look at any other kind of SMD package, that's usually not available, right? The smallest range is usually at 18 degrees or 20 degrees. If you look at PLCC2 or PLCC4 with lens. But with our SMT Lamp technology, we can also create lenses of about 18 degrees and below, right? So that's a big advantage, right? So that can be used in applications like light curtains, for instance. So you have industrial light curtains where you have a big range. So you need a photodiode or photodetector and an emitter. but the distance between those two LEDs is usually some meters, right?
Yeah.
And for this, you need a lot of power, or you need a very narrow viewing angle, right? And for this, SMT lamp is an ideal solution because it's having a very small viewing angle. It's a very directional light in one direction. Yeah. So that's why it's ideal for that one. Yeah.
Yeah.
Then where do I see other infrared LEDs? In fire detectors,
Yeah.
or smoke detectors. You have a photodiode who's detecting the smoke, etc. Right? You have also, if you look into industrial areas, you also have this bottle detection. So if you look in a factory, they are having a camera detecting if the bottle is broken. And the other possibility is it can also see if the height of the water, or whatever is inside the bottle, is correct, right?
Yeah.
So that's also a kind of possibility at the end, right? And there are much more camera systems, of course. You have always some infrared LEDs. If you look at the low-cost ones, you have a lot of through-hole LEDs around the lens of the light. And and there are much more possibilities too.
A nice range there, fantastic. Now I understand your PLCC infrared LEDs are available with special wavelengths. So what benefits does that provide?
Okay, so these are mainly parts for medical and clinical applications, right? So they have a certain requirement to have a range of 820, 830 nanometers, sometimes 870 and 890 nanometers. So they have specific wavelengths they need to create that detection for certain things. Usually you have 880 nanometers as a standard, or 850, or 940 nanometers. Yeah.
Okay, fantastic. And what advantages of, or what are the advantages of LED technology, and how do you see the technology improving in the future?
So, of course, the advantages, I believe, are clear, right? So it's a high reliable part with a very long lifetime, very energy efficient, right? It's used already in any kind of lighting application already, because the consumption of energy is very low. So I think it already helped a lot for the future. So that's very clear. As you can see, the transition is already going on in other areas. If I talk again about video walls, etc., advertisement signs, etc., it's also have a very low consumption of power.
Yeah.
And then, as I said in the beginning, there's of course also this phosphor converted versions of LEDs, which also helps in that area, because the phosphor converted parts are having double the brightness than the standard parts. So customers could drive the LEDs at a lower current in their application to have the same kind of result in terms of brightness, right? This also helps to reduce the intensity, right? And the consumption, sorry. And I think that's very important. So we are also having a phosphor converted amber, for instance, which we are offering. So the standard Allingap amber, which is just coming from the chip, is at minimum 900 MCD. The phosphor converted amber is having minimum 1800 MCD at 20 milliamperes, right? So we are measuring them always against 20 milliamperes, so the customer can easily drive them at 10 milliamperes or even lower in their application, right?
Yeah.
So that really helps to lower the consumption. Yeah. So maybe at the end I can also show this demonstrator, because I believe I forgot this in between.
Yeah, no, please just summarize what it is you've brought with you.
Correct, yeah. So this is a small video wall solution just to demonstrate this also to customers, right? This one here is a small pixel pitch, so it's only having 2.5 millimeters. So the LEDs are already very close to each other, right? So we have 32 LEDs in each row, so in total 1024 LEDs.
Wow, okay.
Yeah. This is a package called 2216. Basically, this just means 2.2 millimeter by 1.6 millimeter, right? So this is, of course, also available in different colors. So this one is the white version for monochromatic signs. But, of course, other colors like red, amber, green, etc. are also available, right? And you, of course, can also build this up in RGB so that you have a full color display, right? So right now we are at a level of 1. If I put it up, you can see that the brightness is really going up here.
Yeah, definitely.
Yeah. So we put a diffuser here on top, So right now the light output is only at 60%.
Wow.
So what they are doing, for instance, for the bus panel signs, they want to have a better contrast, right? Because this is not really looking 100% nice.
No.
So we put this off, right? And this is a dark one, so a dark diffuser. If I put this on, you can easily see that the contrast is much better.
Yeah.
Even we have the same light output, it only gives you a rest light output of 20%.
Yeah.
So yeah, it's not that bright anymore, but it gives a very nice contrast also for the people to look at.
Yeah,
right,
definitely.
At the end.
Yeah, perfect for bus sign applications,
Yeah,
as you
correct.
say.
Yeah, it's ideal. Yeah,
Yeah,
correct.
fantastic.
Yeah. And we also have a package platform which is a little bit smaller than this one. So that's a 1608, so 1.6 by 0.8. So with the 1608, you could even create a 1 millimeter pitch, so even smaller.
Mm-hmm. Fantastic. Yeah.
So yeah, so I thought that's also a nice demonstrator to look at.
Yeah, definitely. And what about these other two that you've brought with you as well?
Okay, the other one I showed you already, the SMT Lamp solution, right? So maybe I can also say that the SMT Lamp solution is unique. So that's a package created by Broadcom already since many, many years. This package is made from epoxy material only with one tooling. Okay, so compared to other parts in the market which are having a lens, they are usually a two components part. So you have the PLCC4 with a lens, they have a plastic carrier package, and there's a silicon lens on top, right? So these are two components. So the lens is a little bit fragile for those applications.
Yeah.
If you look at this one, it's completely made from epoxy with one tooling, like the through-hole LED lamps. So it's very robust, right? And it's ideal for those outdoor applications in this case. Yeah, so nothing can happen. So we have a very long lifetime for these parts. They are also available in all colors, so even the white color with the lens. And you can easily replace the through-hole parts. And of course, also the oval solution. So you can see it on the top row here. This is the oval one with a viewing angle of 40 by 100. As I said, maybe for gas price signs, etc. And we have the round version, which is ideal for highway signs. Okay, on the big highways. Here you need directional light, right? If you are, I don't know, 40, 50 meter in front of the panel, it's very important that you get the direct information, right?
Of course, yeah.
So then you need a 30-degree SMT lamp ideally.
Yeah, fantastic.
And this one is a small demonstrator for the infrared LED. I don't light it up because it's not really showing anything. It's just showing the package types which are available, so the ones which I described before.
Yeah.
So also the side view versions, for instance, the through-hole solution, and the one with the lens, so PLCC parts, etc.
Fantastic. Well, thank you very much for bringing them along to demonstrate today, and thank you very much for your time and your insights.
You're welcome.
Enjoy the rest of the show.
Thank you very much.
Thank you very much.
You too.